Welcome back. Merged mining. So the idea of mining is typically to mine for like one blockchain, like Bitcoin or Ethereum, but not to mine for multiple blockchains at the same time. And merged mining is kind of the idea of doing that, to mine for multiple chains at the same time. So you might find a block for Bitcoin, but you also might find a block for example, Namecoin, another blockchain. So mining is typically quite exclusive to a particular blockchain, right? So each attempt that you mine, so that you change the nonce and you compute the hash, of the block, is an attempt to mine for a particular blockchain. Now the question might be, how can you start a new blockchain that has the same underlying proof of work algorithm, meaning it has the same underlying hash functions as well? Well, you could have, for example, Bitcoin. This is SHA-256 based, and now you can create a Boring coin that's also SHA-256 based. Now, all the miners on the Bitcoin blockchain could jump over to your chain and mine on your chain if they wanted to, because their hardware and software is built to support this kind of proof of work algorithm. Now, the problem is on Bitcoin you can see a tremendous amount of hashing power, while on the Boring coin there's not that much going on. And that means that an adversary, like if a bigger miner would jump over from the Bitcoin pool to this Boring coin pool, then he can basically directly own the chain by having more than 50% of the total processing power. So the idea is to mine a Bitcoin and an altcoin referring to an alternative coin, at the same time. So how can we do this? Well, the Bitcoin Coinbase transaction has no inputs, right? There's no so-called script SIG. This is the input to a Bitcoin transaction. And this is the typical way of performing, of mining for a Bitcoin block. And well, if we translate this would be the typical way of doing this for an altcoin block. Now, if we want to do merged mining, we basically, what we can do is we can here create a Coinbase transaction where we add an input, right? So there's typically no input in a Coinbase transaction, but we can do so. We can basically just amend one. And what we put into the script SIG is the header of the altcoin, so of this alternative blockchain. And by doing so, we basically insert we merge those two blockchains together, right? We can link them together. So this is ignored by Bitcoin because the Bitcoin protocol doesn't care if there's any input in the Coinbase transaction because it's meaningless, right? The Coinbase transaction creates coins out of thin air, and if we add data at this particular location in the chain, well, the protocol doesn't care. But if this content here is a hash of or it says like a block header from an altcoin, which matches a particular target, right? And this target here, that's not the Bitcoin target, but is rather the target of this altcoin. Well, then we suddenly merge mined. So the advantages of merged mining is that it's easier to bootstrap mining power of another chain. And this was also the reason why people introduced this. The disadvantages are that it's quite cheaper for attackers to attack. There are some examples that called coins that we won't go further into here. And the other problem is that there's some inconsistency because miners might not validate transactions, right? So if you have the block header in the Coinbase transaction of the parent blockchain, then you might not validate the contents of the block itself, because the block header contains a Merkle root, which references the transactions of this altcoin chain, and these transactions are not necessarily verified. And that's, if you don't verify in blockchains, that's always a negative and bad thing, and certainly not something that I can recommend you doing. So Namecoin is an example of a blockchain which did merged mining. And we saw events where a mining pool owned like 60 to 70% of the hash rate. And this means this mining pool can quite easily perform double spending attacks and own the chain. So the hash rate of a mining pool should always be below 50% at least. Thank you very much for watching, and see you in the next lecture.